Okay, so today we are starting chapter 4. We're going to be graphing equations in slope-intercept form and working on linear equations and functions this chapter. So first let me start off with what is slope-intercept form? Well, it pretty much says it in the name. It's an equation that has the slope and the intercept, and that's specifically the y-intercept in the equation. So we'll see here. It's represented as y equals mx plus b. So m is the slope, and then b is the y-intercept. So let's identify the slope and y-intercept on the graph below. And then we're going to write the slope-intercept form of the equation of the line. Okay, so here we have a line, and first we'll start with the y-intercept. So the y-intercept is where it crosses. This is the y-axis here. And here's our line. So we want to see at what point. And then we can just kind of count, or you can see on the graph it goes up 1, 2, it's at 0, 3. So that means b is equal to 3. Again, we always use b for the y-intercept, and then m, which we've already encountered before, m is going to be the slope. And so what we're going to do is we're going to count from this point to this point, and I'm going to do rise over run. So I'm going to count up 1, 2, so that's going to go up 2, and to the right 1, 2, 3. So that means m is 2 over 3. So I'm just going to put that all together. So we have y equals mx plus b is the slope-intercept form. We leave y and we leave x in our equation, and we just replace the values of m and b. So that's going to be y equals m was 2/3 x, and then we're going to put plus b, which was 3. And that's how you write the slope-intercept form of an equation of a line. Now, sometimes you just kind of have some information. We don't have the graph, all right? So we're writing an equation of a line in slope-intercept form, but we are given the slope and we're given the y-intercept. There is absolutely no work to do here. Here we have the slope, so that's m, and we have the y-intercept, that's b. So again, I'm going to leave y equals, and then an mx plus b. So m is -3. Put the x back in, plus b, which is 5. And that's it. That's our answer. All right, b. So the slope is -2/3. So that's my m. And the y-intercept is 0. So that's b. So I have y equals -2/3 x. And then I could do plus 0 or just leave it. Okay, if the y-intercept is 0, I just leave it as y equals -2/3 x. Again, if I'm going too fast, you can always slow it down, pause it, or you can rewind. Okay, example 3. We want to write the slope-intercept form of each equation of each line below. This is like what we did in the very first example. So again, I start with the y-intercept. You could start with the slope too, but I usually just kind of look. All right, so this is 5, 6, 7. So b is 7. And then to find to find the slope, I'm going to count from this point to this point. So I go down 1, and then to the right 1, 2, 3, 4. So that means my slope is -1/4. Again, slope-intercept form is y equals mx plus b. So I'm going to have y equals m is -1/4. Don't forget to put the x in there. Often students will forget to put the x. And then plus b, so that's plus 7. Okay, maybe you want to pause it and try b on your own and then see if you get it right. Okay, so I'm going to find the y-intercept, so that's down 1, 2, 3, 4, 5. So right here, b is -5. And then I'm going to count from this point to this point. So let's see, up 1, 2, 3, 4, 5, 6, 7, 8. So we went up 8, and then to the right 1, 2, 3. So rise over run is 8 over 3. So we put that together, we get y equals 8/3 x minus 5. Okay, so now let's say we want to work backwards. Let's say now we have an equation in slope-intercept form and we want to graph it. Okay, so I have kind of this step-by-step, and I'll kind of walk you through the first example as we're going through the steps. So this is graphing equations in slope-intercept form. The very first step, plot B. Again, that's the y-intercept. So when I look at example A, it's good to kind of figure out what pieces we have here. Well, remember, the number at the end, that is B. That's the y-intercept. And then the 1/4, that is M. That is our slope. So if I'm starting with the y-intercept, I always have to start with a point. And if it's at +5, that means I'm going to go 1, 2, 3, 4, 5. And now so step 2, using M, the slope, we're going to count the rise and then count the run, right? So up or down and then left or right, and then plot a second point. So from this y-intercept, I'm going to go up 1, to the right 1, 2, 3, 4. And then step 3, just draw the line containing the 2 points. Okay, so again, just a quick reminder, we started off with B, we started off here at 5, and then since M was 1/4, we went up 4, and then to the right, up 1, and then to the right 4. So up 1, to the right 4, plotted a second point, and then drew the line. Okay, so let's take a look. The next one, we start with the y-intercept, so start with 3. So we go up 1, 2, 3, plot that y-intercept, and then the slope. Now, the slope in this case is equal to 2. I can put any integer over 1 because then I know I can go up 2 and then I'm going to go to the right 1. So from here, 0, 3, I'm going to go up 2 to the right 1. And if you're not sure, you can always do a second or a third point. You can go up 2 to the right 1, and you can keep going in that manner. And then connect the lines. Don't forget to put your arrows. Okay, so sometimes the equation is not in slope-intercept form. So basically what we want to do is solve for y to get it in that form. So I have x minus y equals -3. So I am going to, again, we're solving for y, meaning we want to isolate y. So I have -y, and I always like to put the x in front. Okay. Now I need to get rid of that negative sign. So I'm going to divide everything by -1 here. So I get y equals x plus 3. Again, I'm going to start with B, my y-intercept, so that's at +3. And now when I'm looking at my slope, there's no coefficient in front of x, which really means there's a 1. So m is equal to 1, and again, I can put any integer over 1. So from 0, 3, I'm going to go up 1 to the right 1. And then I'll graph my line. So that's a slope of 1. For B, again, we had a few more of these, so if you want to pause it, try these on your own and then see if you got them right. You can go ahead and do that. So 2y equals x plus 6. So I am going to divide everything by 2 because I want to isolate y. Now, x divided by 2. I want to make that a fraction, so I'm going to put a 1 in front and rewrite this as a 1/2 x so that I can clearly see the fraction in front of the variable. And then 6 divided by 2, that's going to give us 3. So we go here, start with b, and then use our slope of 1/2. So that means we go up 1 and then to the right 2. And then we'll graph our line. Okay, C. So in C, notice that there is no x in C. Really what this means is that we end up with a slope of 0. Okay, so it's as if 0 was multiplied by x to get rid of it. So again, we'll still start off with the y-intercept, which is 5. And if we have a slope of 0, so when it's just y equals a number, this is always going to be a horizontal line. We talked about that in the last chapter. So we're just going to draw a horizontal line straight across, and that's all we need to do to that. So we don't have to plot a second point. Okay, and then D. So again, here I want to isolate y, so I'm going to add 12 to both sides. And let me move it over here. So I have 2x plus 12 equals 4y. So now I'm going to divide each part by 4. So 2/4, so that's really 1/2 x plus 3 equals y. Let me just rearrange that. And I think we had this graph on the previous page. We just had it in a different form. So starting at 3, and we go up 1 to the right 2, and graph the line. Okay, so modeling real-world data. So if a quantity changes at a constant rate over time, it can be modeled by a linear equation. So we think of the y-intercept always represents the starting point, and the slope is always going to represent the rate of change. Remember what we did in the last chapter. We did rate of change, and then we said, oh, well, rate of change of a line is just the slope. So let's look at this last example. The number of girls competing in high school sports has increased by an average of 1/2 million per year. That is a rate of change, okay? So I'm just going to write down here, just to kind of note. So m, that's my slope, that's my rate of change, is 1/2, and million, we'll figure that out at the end, but it's 1/2 million per year. Okay, so that's since 1997. Now, in 1997, there were 2 million girls in high school sports. So in 1997, that is our starting point. So B is 2 million. So for part A, we want to write a linear equation to find the number of girls in high school sports in any year after 1997. So we have y equals 1/2 x plus 2. And that's our equation. And then let's go ahead and graph this. So we're going to start with, so since 1997, so we start with 0, 2, and then our slope is 1, so up 1 over 2. We can go up 1 over 2. We can continue. Or just graph the 2. Now for this one, I don't want to put an arrow going this way because we don't have negative values in this case, so it's just going to be in that first quadrant. And then we want to estimate the number of girls competing in 2005. Okay, so this equation, x represents the number of years after 1997. Remember, 1997 was our starting point. So if we do 2005 minus 1997, that's going to be 8 years, right? So 8 years, that's what I want to plug in for x. So I have 1/2 times 8 plus 2. So I have 4 1/2 of 8 is 4 plus 2. And so we get 6. So estimate the number of girls competing in 2005. So we're going to say about 6 million. And another way we could have looked at this is we could have actually looked on the graph and just seen, although my graph is off a little bit, here, actually it's not, if we look at 8 years after, right, looks like that did end up being 6 million. So my graph is actually pretty good. Okay, so you can go back to the Pear Deck. There's a couple of quick questions just to make sure that you understood the lesson. And then if you finish early, you can go onto my JAG and start the homework assignment, which is a worksheet I posted on my JAG.